The last time we had a video, we have discussed video adapters. We have discussed different intensity. We have seen the bit panels and their related. Also seen the triode, which is generation of using pixels, 3 pixel RGB, and based on that RGB value and intensity values, your colors combinations have been taken place. Also, we have seen the refresh rate. We have seen this cycle phosphorescence property of phosphor material. Okay, we have seen the interlacing also. Okay, and to speed up the interlacing, see, actually interlacing means refreshing the same point again and again, some n number of interval, that is kind of frequency. And we have seen some alternate interlacing, instead of refreshing 1, 2, 3, 4, we are skipping in between, interlace directly after one sweep. We directly start from third scan line. Okay, then our discussion goes to the raster scan and random scan, and there we will stop our discussion with the random scan and raster scan. Okay, now let's in today's discussion we are planning to discuss this kind of discussion, that is difference between random scan versus raster scan, advantage and disadvantage of it. There is some display file and operation on the display file, because display files it input to the graphics unit, and graphics will in turn your beam, electron beam is redirecting according to your command, and their interpreter. Okay, and probably, and in the next line and line segment there is the equation of it, length of the line segment, and some more operation on it, intersection, and from here onwards our equation of lines and their mathematics parts will be starting. Let's start our discussion. What is difference between random scan versus raster scan? You guys also make in 2 lines here the difference between these. Okay, differences. You make it in 2 lines here. First of all, random scan, and in second line, okay, in let's say we can see here. Okay, in the straight line, raster scan. Very first point, take under this point 101, random scan. Write down random scan. Random scan operate by directing. Okay, you note down here, operates by directing the electron beam to only those part of the screen where picture is to be drawn. Okay, where picture is to be drawn. And here electron beam starts from here. Electron beam starts from where? Electron beam starts from top left corner. Top left corner of the screen and moves horizontally. Top right corner of the screen and move left horizontally. Okay, to the right. Right, to the right. So this is the first point covered. Next, second point under this. Okay, diagram creation is easy, so used in engineering and scientific drawing. Okay, It is easy in creation. Diagram is easy. Diagram creation is easy. Okay, so is used in engineering and scientific drawing. And here it is used in animation. Okay, sorry, it is used in animation. Next discussion will be on third point. Likewise, you note down pane plotter and DVST. So here pane plotter. Pane plotter, or we can say DVST and DVST. Actually, DVST is for direct storage tube, that is we discuss. DVST, direct storage view tubes. Okay, devices are used. These devices are used, and here CRT, cathode ray tubes are used. Okay, then here fourth point under this 4.4 to 4, the cost of devices is much higher. Cost of devices is high, and here cost of devices are not. It is maybe say cheaper. Okay, it is little bit cheaper than the available cost. Then fifth point, under fifth point, write down it requires less memory, where it requires more memory. Okay, sixth one, requires intelligent. It requires intelligent electron beam. Okay, that is processor controlled. Okay, processor controlled, and here we can say no such requirement is there. Okay, no such requirement is. So this is the some kind of a few distinguishing criteria for difference and say these things. Moving to the next advantage and disadvantage part. Okay, let's say advantage part. Very high resolution for where random. Okay, random scan. Advantage and disadvantage of random scan, especially advantage part of a random, it is very high. थोड़ा handwriting proper नहीं आता इस पे. Very high resolution. Very high resolutions we are getting, it is advantage, and limited only by the monitor. Some it provides provided with only limited monitors. It is with only limited monitors. So limited monitors are evolved. आफ्टर दैट डीवीएसटी और रैंडम स्कैन के बाद में डायरेक्टली हमारे पास डिफरेंट मॉनिटर्स आए. हियर आल्सो वी कैन से इजी एनिमेशंस आते हैं यहाँ पे. इजी एनिमेशन एंड जस्ट ड्रॉ अ डिफरेंट position and requires less memory, as we have seen in the difference between. So that can be advantage part, required less memory. Okay, so in disadvantage part of this requires intelligent ये भी हो सकता है, intelligent beam लगेगा हमें. Intelligent electron beam is required, which is microprocessor control. Okay, microprocessor controlled. This is kind of a disadvantage because definitely intelligent beam, if you use it, added a cost under that. So that's why that was a very expensive to purchase at that time. So हमें intelligent beam नहीं चाहिए. That's why they have. So there are some kind of advantage, some high graphics, and there they used. Okay. Now limited screen density they provided. Screen density is the approach. It is a problem. Limited density. Okay, screen density, and limited color compatibility. Okay, limited color compatibility. Okay, limited compatibility. So that was some advantage and disadvantage part related to random scan display. Okay, then what is the next topic? Let's say display file. What is display file? Okay, this is also very important topic. Display file पता होना चाहिए कि क्या चीज होते हैं display file and their structure. Yes.
Sir, for raster scan advantages and disadvantages.
हाँ बघायचं आहे का? काय नाही तुम्ही जे सी व्हेरी सिंपल इट इज ये एडवांटेज ये हमने डिफरेंस लिखा है ना डिफरेंस ये डिफरेंस को ही आप एडवांटेज एंड डिसएडवांटेज में कन्वर्ट कर सकते हैं. जैसे ये देखो रिक्वायर्स लेस मेमोरी इट इज एडवांटेज पार्ट. ओके एंड रिक्वायर्स इंटेलिजेंट इलेक्ट्रॉन बीम. सो डेफिनेटली इंटेलिजेंट बीम होने की वजह से क्या होता है वो एक्सपेंसिव भी हो सकता है और ये थोड़ा डिसएडवांटेज पार्ट में आ सकता है एज कंपेयर टू अदर कंट्रोल. And different another is screen density means resolution limited resolution में आता है ये. So limited resolution limited color compatibility simple directly proportional है. ये तीन से 4 इसका disadvantage है. Okay and hardly it is asked in the okay ना अब तक तो नहीं पूछा लेकिन पूछ सकते हैं for in examination because you have the written test but online में अब तक ये नहीं पूछा है. Now display file जो हमें commands provide करती है for redirecting our electron beam. How that line get redirected to whom? Okay, so see display file and its structure. We are all aware that the raster graphics display picture are stored in the frame buffer. Okay, frame buffer means temporary buffer area which hold information about all pixels. Okay, I will write here frame buffers. Frame buffer. Okay, and in turn that will be displayed onto the monitor. Okay, so frame buffer, so it holds information about the whatever. Suppose this frame buffer is holding the character is to be drawn like this way. Okay, character is to be drawn like this way. The information that draw onto the monitor it holds. Okay, so the pixel means it hold information about all pixels, whereas in vector graphics it refreshed display we use in the commands. Okay, to store in the picture we want to store. So vector is refresh. Okay, तो वेक्टर सी व्हाट हैपन, सपोज मैं एक डिस्प्ले फाइल निकालता हूं और इसमें पूरे पिक्सल पिक्सल है ऐसे, मीन्स बफर बीट है ये पूरा बफर बीट, एंड डेफिनेटली इसका कुछ रिजोल्यूशन होगा x बाय y, राइट, x बाय y रिजोल्यूशन होगा। तो सपोज मुझे अगर a ड्रॉ करना है डेफिनेटली, तो मैं ये पिक्सल इनेबल करूंगा। आर यू गेटिंग व्हाट आई एम टेलिंग टू से? दिस पिक्सल गेट इनेबल्ड। ओके, तो इस तरह से उसका एक कंटिन्यूएशन में दिखेगा। The same will be given, the same will be mapped with your monitor screen. Okay, and that's why the corresponding pixel look like some glowing onto the screen, the frame buffer. Okay, but okay, now in the random scan, the random display, the file which are storing are the commands. Okay, to draw the picture, the commands that stores. Okay, so what command here? For example, we want to draw a triangle. So in the random scan, we have to redirect our beam. We have to redirect our beams. For example, this is beam from here to move here at the beginning. Okay, at the begin. So we want to redirect our beam to move here. So definitely for the monitor, we have to redirect our beam to start from this location, go here, then go upward, go downwards like this way. Okay, so go to, right, go to some location is a command, right? Then move from first location to second location, move first location to second location, right? Then again we are redirecting, move second to third, and then move third to again one. Such kind of commands are storing in display files. Okay, now what exactly display files contains? That a display file contains opcode, okay, and operand. ये शायद आपने माइक्रो प्रोसेसर में पढ़ा है, opcode and operand. So opcode means this one, कौन सा ऑपरेशन परफॉर्म करना है, right? So let me write down something. move 10 10 माइक्रो प्रोसेसर में ये कैसे किस तरह MOV 10,10. दिस इज एग्जैक्टली माइक्रो प्रोसेसर 8085 का इंस्ट्रक्शन नहीं है, MOV 10,10. और यहाँ पे हमने किस तरह से लिखा हुआ है, just like, okay, just like. So what is the MOV is called as opcode, and what is this called as operand. ओके, तो ये इसके बारे में डिटेल आप माइक्रो प्रोसेसर में पढ़ेंगे, हमें माइक्रो प्रोसेसर का ये देखने की जरूरत नहीं। हम व्हाट वी आर डिस्कसिंग डिस्प्ले फाइल में क्या होता है। डिस्प्ले फाइल में क्या होता है, डिस्प्ले फाइल में इस तरह की कमांड्स होती है, राइट? तो हमने कमांड्स यहाँ पे लिख के रखे हैं। ओके, ये मैंने एक एग्जांपल बताया, टू ड्रॉ द पिक्चर। नाउ opcode, see, maybe they may be stored some kind of a table also, okay, in the form of tables. For example, let's say opcode and their command. अगर मैं tabulated form में mention करता हूं, तो we are maintaining some tabulated form. Opcode, let's say 1 is for move, second is for draw the line, third is for something else that we don't know, okay, or something that no, something is there maybe. Let's say something, okay, here we are representing this one only, move and line. इस तरह से n number of opcode हो सकते हैं in display file में. We are not we are not asked to write the construction of display line, but what it contains some kind of opcode and commands. Opcode may be contained like this way, some abbreviated as 1, 2, 3, 4, 5 and their corresponding command. One opcode is used for move. Then how this command can be written? This command can be written. This command can be written like this way. Here down the line 1, 10, 10. Isn't it right? 1, 10, 10 like this. And suppose we want to draw a line. Second, draw a line from x to y2 to x3 y3. Okay, likewise. So second command and give the line, I think 30, 30. So how interpreter interprets it? This is, suppose interpreter at that this line 1, it will refer this table at corresponding move. I have to move to 10, 10. So let's say this is the monitor, and for time being assume that we have to move here 10, 10. Okay, let's say P1, point 1, P1, 10, 10. Okay, so first your electron beam is aligned over here, move command. Then draw the line. 2 is for draw the line. See, it refers line command. Line, draw the line 30, 30. So as ideally this is the P2 30, 30. And line will be drawn here to here. Okay, as this. Now suppose second again, what will be the here 15 and above x-axis will be, let's say P3 here, and point will be यहाँ पे 15 आ गया, x में 15, ये हाइट में 10, 20, 30. Okay, 15, 30. Okay, 15 definitely x-axis में यहाँ पे ये half हो गया. Okay, 15, yes, exactly half, and on the top of that, this pixel is to be drawn. Okay, so from here draw 15, 30. So this line will be drawn. Exactly straight line nahi aaya mera. Okay, this line will be drawn from here to here. Then again next 2, 10, 10. Then here from here to here the line will be drawn. Okay, here to here line will be drawn. In this way, a triangle picture will be formed using these commands. Okay, and this is also called as vector graphics. Okay, vector graphics. वेक्टर ग्राफिक्स के क्या एडवांटेज है आपको मालूम है. सी कितना भी स्क्रीन रिजोल्यूशन बढ़े, सी अगर ये स्क्रीन रिजोल्यूशन बहुत बड़ा स्क्रीन रिजोल्यूशन है, ओके, फॉर एग्जांपल लेट्स से अ बिग स्क्रीन रिजोल्यूशन इज देयर, ओके, एंड definitely this will be redirected to here, here and here. Okay, line will be drawn, line will be drawn, line will be drawn. Okay, lines. So lines will be drawn from end point to end points. Okay, so n number of resolution. Let it be n number of resolution. You will get very smooth image इन वेक्टर ग्राफिक्स. क्यों आप में मिलते हैं, कितना भी उसका रिजोल्यूशन बना, शायद मेरे से ज्यादा आप लोग जानते हैं. आपने शायद इसमें क्या बोलते हैं, फोटोशॉप में आपने काम किया हुआ है, एंड इफ यू यूज सम काइंड ऑफ जेपीजी इमेजेस और बीएमपी इमेजेस, Okay, and if you scaled up, right, scaled up, what will happen? It will have distorted, isn't it? पिक्सेलेशन होता है उसका, डिस्टॉर्शन आता है, और हम उसे कहते हैं अपने हमारे लैंग्वेज में इमेज फट गया, है ना? ऐसी कोई बंदे बोलते हैं उस, देखिए इमेज फट गया. व्हाट इज मीन बाय दैट? डिस्टॉर्शन विल बिकम आफ्टर n number of after certain magnifying level. This will, it will look like a distortion image. Your line will be like a distortion. Okay, line will look like a distortion image, not a smooth line. But this is not happen in vector graphics. Vector graphics में pixel plot नहीं होते. वेक्टर ग्राफिक्स में पिक्सेल प्लॉट नहीं हो रहे. वेक्टर ग्राफिक्स में क्या हो रहा है? वी आर गिविंग एंड पॉइंट्स डायरेक्टली एट ईच टाइम. एसवीजी फाइल जिसे बोलते हैं, एसवीजी फाइल, सुपर वेक्टर ग्राफिक्स, स्केलेबल वेक्टर ग्राफिक्स. ओके, आप इसे कितना भी मैग्नीफाई करो, चाहे तो आप पहला नोड यहाँ पे दो, दूसरा नोड यहाँ पे दो, तीसरा नोड यहाँ पे दो, डेफिनेटली इट विल बी फाइंडिंग आउट द स्मूथ लाइन. So we are not concentrating on plotting pixels. Plotting pixel करना ये different engine का काम है, उसमें separate engine होता है उसमें. Okay, but we are giving end points यहाँ से यहाँ. Okay, so that's why super scalable vector graphics में हमेशा आपको एकदम smooth images मिलते हैं. Okay, so that's why बड़े-बड़े जो printers लोग में होते हैं, सो बोलते हैं कि वेक्टर ग्राफिक्स में चाहिए. वेक्टर ग्राफिक्स में क्यों चाहिए? क्योंकि वहां पे जो भी लाइंस बनते हैं, जो भी कर्व्स बनते हैं, इट विल ऑलवेज टेक्स द एंड पॉइंट्स एंड रन टाइम दे विल, algorithms are there, they will regenerate that frames. Okay, so now the discussion is that we have seen what is difference between what display file contains. Okay, display file contains some amount of coding. Okay, some amount of opcode and their commands and related information about this related information means कहाँ से क्या करना है, कौन सा कमांड फायर करना है. एंड ओके, नाउ ये डिस्प्ले फाइल sorry, I will redraw it again because this display file will be given input. Okay, user program, मैं डिफरेंट कलर लेता हूँ यहाँ पे. पर्पल. Let's say user program, one block is there, user program. User program is written into one file. User program get converted into display file which contains series of instructions. Display file will then goes to interpreter, goes under interpreter, and then it will be seen onto the screen. This is the flow. Okay, this is the flow. So usually we are writing this program, a graphics program here. Okay, and ultimately this is done by the system. Okay, okay, so interpreter are there and then it will be displayed onto the screen. Likewise, this is done here. Okay, so we have today in today's session we have just seen what is display file, what display file contains. Okay, it contains opcode and operand, and it is used for random scan display purpose. which is mainly used for high graphics, high resolution SVG files and that kind of file generations. And usually display files having this flow is used in this flow area. User programs use input to the display file then convert using interpreter to draw our object onto the screen like this. So I think the next topic of discussion will be the line and line segment. Okay, uh, I think we can start, no problem. Line and line segment. Before we are starting, let me draw one diagram, and this diagram is also important for you afterwards also. Okay, so ये आपको line ये draw करना है आपको. Exactly vertical आएगा. This is x-axis, this is y-axis. Okay, and one line here. एक लाइन मैं डिफरेंट कलर से लेता हूँ. कौन सा कलर बेस्ट रहेगा? ग्रीन कलर दिखता है कि पता नहीं आपको? ग्रीन कलर. ओके, I will drawing the line from here, this point to here. Okay, and one different, let's say this is the one point and this is another point. Okay, let's say this is x1 y1 and this is x2 y2. You guys also please draw these. Okay, and I will take some projection of this over here and also projection of this over here. I will say this is x1 x2. Okay, in the same way let me point it out, this one. Projection here, projection here. Okay, y1 y2, right? And if I check this one, just join this one. This one, if you join, so we can say this is delta in y. Okay, this much is called delta in y. Why it is called delta in y means difference in y, and this is called delta x. Okay, and this is called delta x, and this is the infinite line. And here this is the cross section of this one. Okay, and this one is called constant c. Okay, दिस इज कॉल्ड कांस्टेंट C. तो ये डायग्राम आपने निकालना है, यहाँ पे हमें ये चाहिए, एंड बेस्ड ऑन दैट वी हैव टू डिस्कस इन couple of section in next time. So what will be the line and line segment? Let's say we can say okay, that we can say the equation of line equation is given by, okay, the line equation is given by, now you well known line equation that you know, mx plus c, okay, y equal to mx plus c, ये लाइन का इक्वेशन है, राइट. इक्वेशन नंबर 1, y equal to, there is a there is a slope, okay, there is a slope, we can say this form is called as slope intercept form, okay, intercept form. This equation is called as slope intercept form, जिसमें slope आया हुआ है m और interception y interception. See here, this is the y interception, okay. If you observe me carefully, this C is this one, okay, and m means changes in y, okay, changes in delta. M means what? There is a slope, there is a slope. What is the formula for slope? We can say delta y by delta m. So m can be found out by using delta y by delta x, or other word to say that there is a y2 minus y1 divided by x2 minus x1. Okay, in other word to say that changes, okay, changes in y divided by changes in x. So this is the well-known formula here, here, that y1 this formula, okay, and there is another formula is available which is called equally follows, and somebody second form. This is the first form, slope intercept form. Second form, the first form, the second form is y minus y1 upon x minus x1 is equal to y2 minus y1 divided by x2 minus x1. This is another equation formula, line, when two endpoints are given, okay, two endpoints are given, and equation number 2, and third form is, okay, third form when interception. ये लाइन के इक्वेशन है, okay. So x by third form, x by a plus y by b is equal to 1, okay. This is directly coming from mathematics, and this is equation 3, okay. And most probably we are using slope intercept form. This form we are using for calculate, okay. So you note down very properly, ये diagram निकाल कर रखो. Next time we will start from here itself.